Moving right along to section 2 of this chapter, we are going to discuss algal blooms. Algal blooms are going to be a kind of rapid reproduction of protists in a certain area, and it's kind of overcome the whole area pretty much. You do have two types. You have saltwater blooms and freshwater blooms, just reminding you that protists do spend their time in moist environments. So we do have protists in freshwater and we do have protists in saltwater, and both of them will bloom at times. Starting off, we're going to talk about saltwater blooms. Saltwater blooms are also called red tides, keeping in mind that they do not necessarily need to be red. The red tide that you were introduced to at the very beginning of the chapter through the dinoflagellates was not red. In fact, it was that bioluminescent blue. And a lot of times that one was pretty safe to be in. As you can see, the people were surfing in it and everything. Two examples of protists that will bloom in salt water are those dinoflagellates that you saw, and as well as diatoms, which you saw. So they were both commonly going to bloom in saltwater environments. What causes red tides is not necessarily clear to everybody. When they do happen, for the most part at least, we do notice an increase in nutrients in the water. This nutrients relates to nitrates and phosphates. So chemicals that have a lot of nitrogen in them and chemicals that have a lot of phosphorus in them. They tend to bloom because the algae thrives off of those chemicals. So when we do get a lot of nutrients in the water, we tend to get algal blooms. A lot of times these are seasonal and can be predicted because when cold water has a lot of nutrients in it from all the dead things that fall down there, it gets upwelled into the warmer water where the algae is, they mix and therefore it thrives. So that could be a natural phenomenon. They also could be influenced by man-made activities through dumping chemicals in water sources, and eventually all water sources do kind of end up to the ocean, or even effects of climate change, which again provide increases in ocean temperature. And when that warmer water mixes with cold water, you get these mix of nutrients and they bloom. There are some effects of red tides, so they can be dangerous in some aspects. One, it's not necessarily dangerous to just go out and swimming in, but when we do get a lot of these protists coming up that have toxins in them, these toxins become at a higher concentration, and therefore you don't want to ingest it. So we are going to close the beach a lot of times when this happens. We are also going to be concerned with animals that do end up ingesting these algae and what we do with them. So if these toxins are high built up during this red tide and we go fishing in the red tide and we catch a fish, there's a good chance that fish contains those toxins as well because it was eating it, and therefore we shouldn't be eating that fish. Red tides do have been known to kill lots and lots of different animals. So here we have a image of some dead fish from a red tide that washed up on shore. There are also cases where the red tides have killed whales, and we've had many different whale carcasses come washing up on shore, very similar to how these fish are up there. So we'll get like a whole pod of whales will die from it because whales will eat this toxic algae and therefore become poison themselves, and they will end up dying. Freshwater blooms happen in ponds and lakes, in freshwater streams, places like that. This process has a scientific name called eutrophication. Basically, again, we're going to get a buildup of algae that is forming due to probably an increase in nutrients, those nitrates and phosphates that have been dumped into this area, whether by natural means or human means. Freshwater, again, can be tampered with through companies throwing sewage waste in there, chemical wastes into the fresh water. Simply being next to a farm, if you plant a farm and you use fertilizers, Those fertilizers, again, you want to increase the growth of your plants on your farm, but when it rains, all that fertilized soil gets washed into your nearby tributaries and lakes and different freshwater sources, and therefore those nitrates and phosphates can spark algal blooms. Why is eutrophication a concern? Here's your step-by-step guide on what eutrophication actually does. Basically, eutrophication is going to increase the production of algae. So I'm going to get a whole bunch of algae. And then my algae is going to be on the surface trying to get all that sunlight. So as you can see in our picture back here, all this algae was on the surface now. And we got a whole bloom of it, and it's pretty much covering all the surface, and therefore we're not getting any sunlight to reach below it. If we can't get any sunlight below it, all the organisms that need the sunlight are going to die. All the algae is taking it from them. They're not getting their sunlight. They're not going to make their food. They're going to die. When they die, they sink to the bottom. Once they're at the bottom, we have our autotrophic, or not our autotrophs, our heterotrophs that are going to come and start breaking it down. So we get our decomposers coming in. These are bacteria, or other types of fungus that can thrive under there, and they're going to start breaking down these dead organisms. They're going to thrive, and we're going to get a whole bunch of these bacteria now because they got a whole bunch of things to feast off of. We're going to get so much bacteria that these bacteria are actually going to start hogging all the oxygen that are in the water, and therefore we're going to deplete the water of its oxygen supply. So now the water is not getting sunlight to produce more oxygen into it, and it's run out of the oxygen that it has in it, and therefore all the other organisms, your fish and your crustaceans that need that oxygen, are going to start to die off. So eutrophication can destroy the ecosystems of your freshwater ponds and lakes.